Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to discuss about the methods of preparation of alkenes. That means we are involving various other chemicals so as to prepare basically alkenes. So what are the methods that from which we could prepare alkene? Let us check that out. So there are few processes where we could convert different chemicals to alkene, and starting with the first one, that is we could prepare alkene from alcohols. Second, from alkyl halides. From vicinal dihalides. And the fourth, from alkynes. So these are the main four molecules or main four substances through which we could prepare alkenes, that is from alcohol, from alkyl halide, from vicinal dihalide and from alkyne. So these are the organic compounds from which we could prepare alkenes. So let us talk, and there will be various processes that would be involved in this conversion. So we are going to discuss about that in a deep detail, but let us start with the first one, that is how can we prepare alkene from alcohol and what is the process that is involved in that. So let us talk about that one. That is from alcohol. So let me give you a short idea that how the alkene is being prepared from an alcohol. So let me give you an idea about that. Suppose if we have an alkane or an alkyl group, as it has been attached over here, as you could see, and this is basically an alcohol. So this organic compound is basically an alcohol, and from which we have to prepare an alkene. So as you could see that there is basically carbon-carbon single bond over here, and we could see that OH is also been present over here, as along with the hydrogens are been present over here, making this to be called as basically alcohol because of the presence of the OH group or the hydroxy group that we see. If we have to convert this into an alkene, then the only thing is we have to remove this OH along with this hydrogen. The reason behind that is this is known as beta elimination. Why? Because as you know that this OH is being attached to a carbon atom, and that carbon atom is supposed considered to be the alpha carbon atom, while that of the another carbon atom which is being attached to the beta to the alpha carbon atom is known as the beta carbon atom. So in this case basically elimination reaction takes place where one OH will be removed from the alpha, while the one hydrogen will be removed from the beta carbon atom. So if the two of this substituents, that is the OH and the hydrogen, if they gets eliminated, then we could prepare a alcohol. For example, in this process, suppose if I've heated it and in the form of, suppose by using a concentrated H2SO4. So what will happen, basically H2 will be removed, and the reason that H2 will be removed very easily, the reason because of the H2SO4, because H2SO4 is considered to be the dehydrating agent, and if this happens, then H as well as H will be removed as H2O, and the only thing that will be left out is basically this structure, that is R C H C H H. But the valency of carbon is not being fulfilled, so we can fulfill it by adding a double bond, because this happens by either can happen by a homolytic fission or that is heterolytic fission. And what happens is that is the bond will be appearing over here when the H and the OH gets eliminated from this region, or from this molecule, that is in the form of partial H which is positive and partial negative which is OH minus. So that is the thing that it has been formed. So now we can prepare basically alcohol to an alkene. So this is a kind of a short example that I have expressed about how can we convert an alcohol into an alkene. So let me give the mechanism of that also. So the mechanism or the reaction or the process that takes place in this conversion is basically beta elimination, and this kind of process where one of the small molecule is been eliminated is from the molecule is known as beta elimination by forming a carbon-carbon double bond known as alkene. So now let me explain this with an example. So that was a general reaction where we have converted an alcohol to an alkene. Suppose if we have an alcohol like ethyl alcohol. In this case, we can't take methyl alcohol, and why? I will tell you. So first of all, suppose let me consider the ethyl alcohol. So ethyl alcohol has the structural formula like this one, as I have mentioned over here. So the name of this would be ethyl alcohol. And the only thing that we have to do is we have to do beta elimination. That is, we have to remove that is a small molecule from this one. That is from this molecule. So have you noticed that we have removed OH and H? That is, we have removed a water molecule. Basically, what we have did is we have did a process known as dehydration. So that is what I am going to express about. That is. So the process that has been involved in the removal of the H2O from an alcohol is basically known as dehydration, because as the name itself suggests, dehydration means removal of water. But this removal of water can't take place by its own, or it won't take place by only heating. We have to provide certain conditions for that. And what are the certain conditions? And those conditions are basically, suppose if this is a primary alcohol, if we have, and for primary alcohol we need basically 95% concentrated H2SO4, and we have to heat it, or else we could use alumina. Alumina is nothing but Al2O3. So Al2O3 is what we use, but this heating condition is of a particular temperature. So a particular concentration, a particular temperature is been required. So for this instant, for suppose if this is a primary alcohol, if we know as a primary alcohol, and we are reacting it with 95% of H2SO4, then the heat that is been required, or the temperature that is been required in this process is basically 413 Kelvin. So in this process, suppose if we are using 95% of H2SO4 and not suppose Al2O3, because now we are concerned with basically usage of the dehydrating agent, basically known as sulfuric acid. So in this process, what will happen is the OH and this H, this both will be removed as H2O. And in this case, the thing that will be left with us is that is CH2 and CH2. That would be written as, this is basically known as ethene. So this is has happened because of the removal of H2O from the alcohol, making this to be called as a dehydration process, and moreover we could call as a beta elimination process in presence of 95% of H2SO4. So this is what I have made an example. So, but beta elimination will take place only if we have an alpha carbon atom as well as beta carbon atom. But in methanol doesn't have a beta carbon atom. That is the reason we cannot do the dehydration for the methanol. That is the reason the minimum we need 2 carbon atoms of an alcohol that consists of 2 carbon atoms, and that is ethyl alcohol. So this is the ethyl alcohol from which we have converted to an ethene. And talking about the another catalyst, that is the Al2O3, or we could say it as alumina. So even alumina can be used, but the temperature that is required in this process is basically 623 Kelvin. And now let me talk about the presence of, suppose if we have converted an alcohol into an ethene, that is an alkene, and in this case suppose if we are using Al2O3. So there are 2 different phases and there are 2 different conditions that we are going to use. Suppose if we are using 95% of H2SO4, then the condition of the alcohol, it should be of liquid phase, and then only the water molecule will be unlimited in this process. And talking about this is Al2O3. In this case, basically the alcohol should be in the gaseous phase, and that is the reason that it has been called as gaseous phase dehydration when we are using Al2O3. So there are two different conditions, but ultimately the thing is we will get an ethene. In both the cases, suppose if we are using, we will get an ethene. So this is the one which we have used a primary alcohol. So suppose if we are using a secondary alcohol, and that alcohol, suppose it undergoes a dehydration process. So what are the different conditions? Even that conditions are being critical, and that are being basically should be considered in our mind, so as to get a perfect answer or get a perfect condition to obtain ethene, or the method of preparation that we say for ethene. So now let us consider for the another example. Suppose in this case, suppose if we have to prepare an alkene from a secondary alcohol, and the secondary alcohol can be written as, suppose if I am writing in this way, as if so this is a secondary alcohol. The reason behind that is this OH is been attached to that carbon atom, it has been attached to that carbon atom, which has been attached to two different carbon atoms, making this to be called as a secondary alcohol. And talking about the name of this alcohol in terms of the IUPAC, as we know that it is the straight chain of carbon atom which consists of 3 carbon atoms, and the OH has been attached to the second carbon atom, making this to be called as basically 2-propanol, or we could also call it as propane 2-ol. And suppose this is a that is secondary alcohol, and in this case also we have to use concentrated H2SO4, but the percentage of the that is the concentration of the H2SO4 will differ. It won't be 95%, because that was earlier one that we have taken an example of ethyl alcohol. It was primary alcohol, and now we are taking the example of a secondary alcohol. So the percentage will differ, and in this case the percentage will be, suppose, 60% of H2SO4, and we'll heat it, and the temperature that is been required in this process is basically 373 Kelvin. So this is the temperature that is been required. So now how the elimination will take place? So either this OH will, since it is a secondary alcohol as we have mentioned over here, so this OH will now be eliminated by removal of H, either from this carbon atom or either from that carbon atom. So because this is such a compound that we have taken which is very symmetrical, so in this case suppose this H will take away this OH, and instead of that what we will get is the removal of H2. So H2 will be removed, and the thing or the product that will be obtained in this process, that is, we could write it as CH3 CH double bond. Here double bond will happen because elimination is a process in which a saturated compound is converting into basically an unsaturated compound. So therefore here we would get double bond CH2, making this to be called as prop-1-ene. So this is how we have converted a secondary alcohol to that is propane 2-ol to prop-1-ene. So this was a secondary alcohol, and let us try for, and not only for propane 2-ol, we could also try for, that is butane 2-ol or any kind of secondary alcohol, but the condition would be in a favor, but the condition should be of a favorable condition, and then only the reaction would happen. And again it is a dehydration process, and that is known as a beta elimination process. So now let us move on with the further one, that is let us talk about the tertiary alcohol, that is dehydration of tertiary alcohol. So the reason behind that I will talk about later, that why the conditions are being, or why the concentration is being less used of the H2SO4. So let me give you an example of a tertiary alcohol, that is CH3 C. So the common name of this alcohol is known as tertiary butyl alcohol, but talking about the IUPAC name, and IUPAC name which we prefer a lot, the reason behind that is we cannot, we don't have to learn the common names of everyone. The only thing is we have to follow the IUPAC rules, and according to that we have to name that. So suppose if this is the longest chain that we have of the carbon, and in that what we are observing is, we are observing that on the second carbon atom methyl group is been present, so we could name it as 2-methyl, and the total number of carbon that are being present in a straight chain is 3, making to be called as propane. But the second carbon atom consists of OH, basically an alcoholic group. So therefore the name of this will be 2-methyl propane 2-ol. But this is actually a tertiary alcohol. And in this process, suppose we have to dehydrate it. We have to dehydrate in such a way that this OH will be removed along with one hydrogen of the methyl groups that are been attached to this carbon atom. And suppose if one hydrogen is been removed from this carbon atom, then the product that would be obtained by removal of H2 will be, it will be in this manner, that is CH3C CH3, and here will be basically double bond CH2. So this is the product that we would get. But what would be the condition? The condition would be different. Again, the H2SO4 will be used. We could easily use H2SO4, but the it is not necessary that we should use a concentrated solution. In fact, in this case, we are using 20% H2SO4 with a temperature of basically 353 Kelvin. So this is the temperature that we have to provide, and this is the product that we have obtained. And the name of the product, according to IUPAC, it would be very much easy because we have did a lecture on that, and it would be, I would consider it as number 1, 2, 3, and this would be considered as 2-methyl. Since I have no space, but I would write over here as prop-1-ene. So ultimately, we have converted an alcohol to an alkene, that is from by using dehydration process and known as beta elimination process. But it is not necessary that beta elimination process is always a dehydration process. There are further things that we are going to talk about. So in observing, so coming back to the theory, observing this concentration, that is, it is 20% for tertiary alcohol, and for secondary alcohol it was 60%, and for primary it was 95%. The reason behind that is the reactivity or the elimination of the OH group from this molecule is very much easier in case of it when it is tertiary. The reason behind that is, as you could see, that there are 3 methyl groups that are been surrounded to this carbon atom, and this all 3 carbon atoms or all these methyl groups have plus I effect, or that is plus inductive effect. So that's the reason they will induce the OH to be removed, and that's the reason they will have an effect on this carbon atom, making this OH to be removed very easily, and that's the reason the OH will be removed by an elimination of OH along with H. So this is the process where the dehydration will take place very easily, and that's the reason the condition is not being required at high temperature. Even at low temperature, that is at 353 compared to the primary one, it can be used, and with low concentration also the dehydration can happen. So talking about the secondary one, the secondary involves of basically, as you could see over here, that this OH has been attached to the secondary carbon atom, making this CH3 and this CH3 to have a plus inductive effect on this carbon atom, and that's the reason OH will be eliminated very easily. And if OH would be eliminated, and that's the reason we don't have to require a to give a higher concentration of H2SO4 or higher temperature, and the process will go on in a simultaneous process, and comparatively to that of the tertiary, comparatively to that of the primary one, and it will go on very easy. So these were the few examples that I have talked about the dehydration process, or how can we prepare an alkene from an alcohol. So what kind of question if they would ask? Suppose if I am telling this kind of question, like suppose if we have a question like this one, that is, how will you prepare prop-1-ene from propanol? This propanol indicates the primary, that is alcohol. In the example that we have taken the secondary alcohol, that is propane-2-ol, but now we have to take that is the primary one, that is propane-1-ol. So how can we write the equation, or how can we give the conversion of basically a propanol to propane? So that is the main concept that we are looking about. So if we see that we have to prepare basically prop-1-ene from propanol, so the main thing is we have to prepare propene from propanol, that makes us to write the propanol structure on the left hand side, that is on the reactant side. So we should not get confused, because what they are asking is we have to prepare this from propane 1-ol. So that's the reason this propane 1-ol should be on the left hand side. So for that we could easily make that structure, that is CH3 CH2 CH2 OH. So this is basically propanol or propane 1-ol. So now we have to convert into prop-1-ene. So that is the reason that we are using, we will heat it with a temperature, and yes, we will provide H2SO4 in this reacting mixture. So therefore H2SO4 will be required. But what would be the percentage? Since it is a primary alcohol, so primary alcohol would require basically 95% of the concentration of H2SO4, and the temperature that would be involved in this case is basically 413 Kelvin. And it depends on the molecules also. So for an instance, suppose I have used in this manner, so at least 95% of H2SO4 is been required and 413 Kelvin has been required. And now the elimination would take place with the beta elimination. As you could see that this carbon is been attached to the OH one, so therefore this one is called to be the alpha carbon atom, while the carbon atom which has been attached to the alpha carbon atom is called to be beta. And in this case basically the OH will be removed from here, while the H will be removed from the beta hydrogen, from the beta carbon, that is beta hydrogen will be eliminated from this thing. So the answer or the product that we could get is basically by removal of H2O and by the formation of CH3 CH, because one H has been removed from here. Among the two, one H has been removed from here, and this OH is also removed from here, making us to the only thing that has been left is double bond CH2, which is known as prop-1-ene. So this is how we can convert a propanol to prop-1-ene. So this is how the question would be asked. So this was an example of the first one, that how can we prepare alkene, that is the first method of preparation from an alcohol. So now let us move on to the next one. And the next one is basically from alkyl halide. Alkyl halide, suppose in this case also the elimination process would take place. Let me give an example. So it is just like similar to that of the previous one that we have did. In the previous one, what we have did is we have involved OH or the removal of OH, but in this case we will remove a halogen atom. How? Let me give you an example. So let me give you an example. So I'm not including here as an alcohol, I'm introducing this to be called as an alkyl halide. So that's the reason I will write it over here as X. And the thing that we have to do is, suppose if we have to convert this into an alkene, then what we have to do is we have to remove this halogen atom along with that of this hydrogen atom. So suppose if this and this is also a kind of the beta elimination. The reason behind that is, suppose as you could see that this X is been attached to that carbon atom, and that carbon atom would be called as basically alpha carbon atom, and the carbon atom which has been attached to the alpha carbon atom directly will be called as beta carbon atom. So what will happen is a hydrogen of a beta carbon and a halogen atom of an alpha carbon, the both will be eliminated, and in such manner it will be called as beta elimination. And talking about this thing, then H and X, if both will be removed, and the only thing that will be left with us is basically RCH. And here, because of in every kind of elimination reaction, a single bond is converted into a double bond, or we could say a double bond is converted into a triple bond. So now in this case what will happen, the single bond between carbon and carbon will now be converted into carbon-carbon double bond and having CH2 attached over here. So in this case basically we have converted basically an alkyl halide. This was an alkyl halide. So an alkyl halide is now been converted into basically an alkene, as we could see. But This is only possible if we have removed the HX, or as we could see, and the removal of HX, that is a hydrogen and a halogen atom, makes us to be called this kind of reaction as dehydrohalogenation. So that is the main kind of or that is the main kind of process that happens in this kind of elimination, where one hydrogen and one halogen atom is being removed from an alkyl halide. So basically this is known as dehydrohalogenation, and the mechanism that takes place in this process is basically known as beta elimination process. And there are also few conditions that from which we could eliminate this kind of HX, and the reaction can be make and the reaction can be possible while converting an alkyl halide to an alkene. So let me give you a short example. It is very similar to that of the previous one, but instead of OH we'll write a halogen atom. So suppose if we have this one, that is this is ethyl bromide, because the number of carbon atom here is 2, and the bromine atom is been attached over this atom or this carbon atom. So talking about how the reaction will take place while converting an alkyl halide. This is an alkyl halide, basically known as, I would write the name over here as ethyl bromide. Well, let me tell you, this ethyl bromide is nothing but the common name. While talking about the IUPAC name, the IUPAC name would be, that is bromoethane. So in this process, if we have to convert an alkyl halide, or especially bromoethane to ethene, then the reactant that we have to take in the consideration is basically KOH. But the main thing that we have to keep in our mind, suppose if we have taken aqueous KOH, then this would give us a substitution reaction. While if we have used an alcoholic condition, or we could write it in this manner also, in an alcoholic condition of KOH, then this would lead to an elimination reaction while forming of an alkene. So how the reaction will take place? Let me give you an example in this case only. So we have to heat it. So what will happen basically? The potassium will take away the bromine atom, so making as a byproduct as KBr, while this OH will take away this hydrogen to form as H2O. And that's the reason even heat is been playing a very vital role, because to eliminate the water, basically heat has been required. So that's the reason that this OH will be along with this H to be removed as water. Then the only thing that has been left with us right now is basically CH2. And here, because one bromine atom is been removed from the alpha carbon atom, and one hydrogen is been removed from the beta carbon atom, making this to be for formation of a carbon-carbon double bond, or we could say this is the beta elimination process. And now we could say that the product is CH2 double bond CH2, naming as ethene. So this is an example that what we have to. And yes, this was a general thing. So this was a general example that I was mentioned, and I didn't mention over here the reactant, but this was an example where I have mentioned the reactant, that which reactant we have to use. And this was a alkyl halide, which is basically primary alkyl halide. So talking about halogens, and we know that in halogen family, fluorine, bromine, chlorine and iodine are been present. So among this, which one are more reactive? Even that is what we have to keep in concern. And now since we have mentioned about the primary alkyl halide, we could also do this kind of process in secondary alkyl halide, and in tertiary also, for tertiary alkyl halide also. So let me first of all give you information about the thing that which halides are basically more easy to form ethene, or they are more easy to form alkene. So suppose let me give you an example. So talking about the alkyl halides, basically when it comes to the reactivity, then alkyl iodides are basically more reactive than that of alkyl bromides, then that of alkyl chlorides. That means if we have to make a process to undergo in a dehydrohalogenation process, that is this one that we have already mentioned over here. So in that case, basically the alkyl iodide, suppose if we are using, then that will give us more better product, because in this case, talking about a more deep detail, iodine are the one which have a bigger atomic size. So because of which they can eliminate easily from the molecule of alkyl halide. So if they eliminate very easily, then obviously by the conditions that we are maintaining, so by that hydrogen of the beta carbon atom will also be removed, and hence we could form that is a beta elimination process, and we could say that an alkene can be obtained. So therefore alkyl iodides are more reactive than that of the alkyl bromides, than that of the alkyl chlorides. So this is the one that we have mentioned over here. And talking about the reactivity, reactivity of primary, secondary or tertiary. So since talking about the tertiary one, in the previous lecture also that we have, that is in the previous preparation also, that is for the alcohol, we have got to know that tertiary alcohols are more readily to give alkenes. So similarly here also the tertiary alkyl halides are more reactive than that of the secondary and then that of the primary alkyl halides. So now in this case, let me give you an example of a secondary alkyl halide, because the primary one has been already done. So let me give you an example of a secondary one. So suppose if we have an alkyl halide which is nothing but a secondary alkyl halide. The reason behind this is known as secondary alkyl halide because the bromine is attached to a carbon atom, and that carbon atom is attached to two different carbon atoms, making this to be called as a secondary alkyl halide. While specifying the name of this compound that we have, or this molecule that we have, the IUPAC name of this one would be basically, we could name the position of the bromine first. So therefore the name of this would be 2-bromo, and the total number of carbon in this case is basically 3. So therefore we could name it as 2-bromopropane. So this is basically an alkyl halide, and to form an alkene, obviously it has to undergo the process known as dehydrohalogenation. But this is only possible if we have used a proper reagent. So in this case, we are using KOH, that is potassium hydroxide, but the condition should not be aqueous; it should be alcoholic. So the alcoholic KOH is being used. So if alcoholic KOH will react with the secondary alkyl halide, especially that is 2-bromopropane, then this bromine atom would be removed from the alpha, that is this has been attached, the bromine which is attached to the carbon atom. Suppose if that is considered to be the alpha carbon atom, and this carbon would be called as basically the beta carbon atom. So in this case, basically one hydrogen of the beta carbon atom would be eliminated so as to form basically HBr. And now the thing that has been left with us is basically CH3. Here the CH will be retained as it is, while here only one hydrogen has been removed in the form of HBr, as you could see over here. So therefore CH double bond CH2 will be formed. So in this case, basically I have converted a secondary aldehyde into an alkene, and the name of the alkene is basically, when I will name it in case of IUPAC nomenclature, then this will be called as prop 1. So this is how we have converted. Again, we have converted an alkene from a secondary alkyl halide. Similarly, for that we could also do it for the tertiary one. And so let me give an example of that also. So in this case, suppose if I have taken an example of a tertiary alkyl halide like this one. So if you notice that this is very similar to that of the previous one, that is a dehydration process, in which instead of the OH, we are writing, or we are substituting it within halide group, and that is the thing, and every mechanism would be same. And because the only thing is we have to convert a particular substance into an alkene. So suppose this is what we have taken, and the name of this would be, in terms of a common name, it would be tertiary butyl bromide. And talking about the IUPAC name, then it would be similar to that of the previous one that we have wrote, that is, it would be 2-methyl, and again the name of this would be 2-bromo, that is propane. But as we could see that the methyl is the one which starts with M, and we know that we should follow the alphabetical order, so therefore we could also write it as 2-bromo 2-methyl. I would write over here 2-bromo 2-methyl, that is propane. So this is what, and the thing is we have to convert this into an alkene. So suppose, and even this is an alkyl halide, so therefore we can't use any kind of sulfuric acid in this process. We have to only exclusively use that is KOH. So therefore KOH will be used. And moreover, if we could say, let me just improvise this thing. This K will be actually be removed with the Br to form as KBr, while this OH will be removed and it will remove the hydrogen so as to form basically H2O. So ultimately the product will be the same, but yes, we have to concern about the byproduct also. KBr and H2O will be the byproduct, and in this case basically now K will be removed along with that of the bromine atom, and this condition should be of alcoholic, so that KBr will be produced. And since this is an alpha carbon atom, so the bromine which has been attached to the alpha carbon atom, that will be removed in the form of KBr. While talking about the beta carbon atom, the hydrogen that has been involved in the beta carbon atom, that would be removed with that of the OH of KOH. So in this case basically H2 will be removed, and that's the reason we are involving in the chemical equation, we are involving this triangle, that is known as to be, we are heating the solution or we are warming the solution, and so as to obtain that is the final product, that is known as CH3 C CH3 double bond CH2, and the name of this is basically 2-methyl prop-1-ene. So this is the similar product that we have obtained earlier also, that is from alcohol, that is from a tertiary alcohol that we have took an example. So this all kind of, that is what we have experienced till now, that is from alcohol and from that is alkyl halide. Only one kind of reaction takes place in this case, is basically that is known as beta elimination, while the process is known as the different kind of process it is been known. That is for the first one, that is for alcohol. If you have to convert an alcohol to an alkene, the name or the kind of reaction that takes place is known as dehydration. While talking about the conversion of an alkyl halide to an alkene, the name of that is called as dehydrohalogenation. So these are the two terms that we have talked about, and now let us move on to the next one, that is how can we obtain, or how can we prepare an alkene from vicinal dihalide. So let us talk about that. So now we are going to prepare basically an alkene from a vicinal dihalide. So actually the first thing is we should know what is vicinal dihalide. Vicinal, as the name itself suggests, that the two halides would be vicinal to each other. Let me explain you with an example. Suppose if we have an alkane like this one. So this is the one which would consist of basically two halogen groups. So suppose that two halogen groups are attached to each other in this manner, that is adjacent manner. As you could see that both the carbon atoms are being attached with the halogen atoms over here, and they are not far apart, they are adjacent to each other. That's the reason they are called to be commonly they are called to be basically vicinal dihalides. And suppose if this X would have been present over here, means if the both the halogen atoms are being present on the same carbon atom, then that would have been called as geminal dihalide. But now we are concerned with vicinal dihalide, and the main thing is we have to convert a vicinal dihalide to an alkene. So this is only possible because in alkene, alkene is nothing but a hydrocarbon which is consisting of a carbon-carbon double bond. So in this case, we could obtain alkene, but the only thing that is we have to remove is we have to remove these two halogen atoms. So this can be easily removed by. So this is the generation that I am telling you. So we will use basically zinc, and in presence of alcohol or in alcoholic condition, and we will heat it. So what will happen, as zinc has a capacity, or we know that zinc has an oxidation state of +2, and this halogen has an oxidation state of -1. So making the zinc to carry the both, or to remove both the halogen atom in the form of ZnX2. And in this case also an elimination process will take place, and the double bond will be between these two carbon atoms, and hence we will get RCH double bond CH2, making this to be known as an alkene. So this is a general reaction that I have expressed, and let me give you a few examples of that. So this is the main concern that we have to take, that for conversion of a vicinal dihalide to an alkene, zinc is being used, and in presence of an alcoholic condition, and we have to heat it. So let me give you an example, a very simple example, or the first member of the vicinal dihalide, like this one. That is CH2, CH2, Cl. In this case, I am taking the halogen atom to be known as chlorine atom, and what would be the name? Even the name is very important, and we have it in our IUPAC nomenclature also. So as we could see that both the substituents are basically the chlorine atoms, and if I would consider this as the carbon number 1 and this as carbon number 2, and for what we have to name it, so the name of this would be basically 1, 2, because two chloro groups are present over here, so therefore 1, 2 dichloro. And the total number of carbon that is present in this molecule is basically 2. So therefore the name of this would be called as 1, 2 dichloro ethane, and for which we have to convert this into an alkene. So the thing that we are required is basically we will use zinc, and zinc is basically a solid material, so therefore we'll use it in presence of a solvent like suppose alcohol, and we'll heat it. So what will happen, obviously zinc will take away this 2 Cl in the form of ZnCl2, and the only thing that will be left with us is basically CH2 single bond CH2. But is the valency fulfilled? No, the valency is not fulfilled. That's the reason we what I am trying to say is the breaking of the chlorine and carbon bond can take place in homolytic fission also, so as the double bond would be over here, and that's the reason we could find a double bond over here, and this is known as basically ethene. So this is how we have converted a vicinal dihalide to an alkene. So now let me give you another example of a vicinal dihalide. Suppose if we have a molecule or a compound like this one, and in this case, suppose if we have mentioned over here 2 halogen atoms over here, so this is also called to be vicinal dihalide. The reason behind that is, as you could see, that both the halogen atoms are being arranged in such a manner that they are attached to the adjacent carbon atoms, and that's the reason they are called to be vicinal dihalides. And the thing is, we have to convert this into an alkene. But before converting into alkene, let us understand what would be the IUPAC name of this structure. So talking about the IUPAC name, I would consider this to be the carbon number 1, because according to the IUPAC name, the halogen atom should be attached to the carbon atom, and while numbering, it should given a very least number. So therefore, this would be considered as the first, second, and third. And talking about the nomenclature of this thing, so therefore this would be called as basically 1, 2 dibromo, and the total number of carbon that are present in a straight chain or in the longest chain in this case is basically 3, so making this to be called as propane, having the parent name as propane. And in this case, what we have to do is we have to convert this into an alkene. So only one thing has been required, that is zinc has been required in this process. And yes, that is the reason that what we have did in our lecture, that is we have converted an alcohol to an alkene, and that is an alkyl halide to an alkene. So therefore different conditions are being required. So even this in this condition also different things are being required, different reagents are being required. So in this case basically we are using zinc in presence of an alcoholic condition, and we are going to heat it. So the only thing that we know that zinc has the oxidation state of 2, or it is a divalent when it forms a salt. So therefore zinc will form, that is ZnBr2. And along with that, the only thing that will be left with us is basically we could write it as CH3 CH, and here suppose if homolytic fission happens in this manner, so therefore CH double bond CH2 will be obtained, and the product name would be basically prop-1-ene. So this is the product that we have obtained, and this was an example of a vicinal dihalide. So it is very easy to understand, but let me go on the further thing, and let us prepare alkene from an alkyne. So let us talk about that. That is from alkyne. How can we prepare alkene from alkyne? So that is a thing that we have to make a concern. We can't use the complete hydrogenation process. What I am talking about, let me explain you. Suppose if we have a alkene like this one, as I have represented over here, and as we could see that there is carbon-carbon triple bond over here. And in this case, suppose if I have used a hydrogenation process, or if I have used hydrogen molecule in presence of Raney nickel. So what will happen in presence of Raney nickel as a catalyst? What will do? It will convert all the unsaturated bonds to a saturated bond. So that means what I am trying to say is it will convert, as we know that Raney nickel is the one that converts the double bond into single bond in terms of the hydrogenation process. While in this case also, suppose if in this case we have introduced hydrogen, and in presence of that is Raney nickel, then the triple bond will be directly converted to ultimately it will be converted into carbon-carbon single bond. That means alkyne will be converted to alkane, but this is the thing that we don't need. We need alkene from alkyne. So that is the reason that what we have to maintain is we have to stop the reaction up till a limit, and that kind of retardation is been done by the use of a special kind of catalyst. And what is that catalyst? Let me talk about that also. So again, the hydrogenation process will take over in this place, but the catalyst would be basically platinum or palladium in presence of CaCO3, and that is lead acetate in presence of lead acetate also. So the catalyst that we have used over here is basically known as Lindlar's catalyst. So I will write over here so as to make you understand. It is known as the main feature of this catalyst and this kind of hydrogenation process is it won't let the conversion of a double bond to a single bond. It won't convert a. The main feature of this catalyst is it doesn't convert carbon-carbon triple bond to carbon-carbon single bond. It converts the carbon-carbon triple bond to up till carbon-carbon double bond only. That is the reason that in spite of using hydrogen and in spite of forming a hydrogenation process, it won't convert a unsaturated carbon-carbon triple bond to carbon-carbon single bond. So the answer that we could get, or the product that we could get in this case, is basically R C double bond C H, and here it would be one hydrogen of and another hydrogen. So in this case basically we have prepared an alkyne, we have converted an alkyne to alkene. So this is the thing that we have used, and the main thing is we have used the catalyst known as Lindlar's catalyst, basically palladium, that is palladium or platinum in presence of CaCO3 and lead acetate. So let me give you an example in this case. Suppose if we have the smaller member of an alkyne, that is in terms of IUPAC name, the name of that would be ethyne. And in this case, suppose if I am using hydrogen and in presence of suppose Raney nickel, So what will happen is I would require basically 2 moles of hydrogen so as to obtain a carbon-carbon single bond, that is CH3 single bond CH3, which is basically known as ethane. But what if I use the same reactant, that is the same ethane, and I've let it to undergo hydrogenation process, because hydrogenation process is the process where hydrogen is been involved, or where the double bond is been converted into a smaller number of bonds, that is if a triple bond converts into double bond or double bond converts into a single bond in that process. So in this case what I am using is I am using Lindar's catalyst, that is palladium in the presence of CaCO3 and in presence of lead acetate. So suppose if this is what we have used, so the only thing that we will obtain is basically CH2 double bond CH2. So this is the product that we would obtain, and we won't obtain the further part, that is we cannot obtain alkane, that is we cannot form ethene if we have used PDCaCO3. So therefore this acts like poison, or it retards the reaction to form another kind of product or to go under further hydrogenation process. So this is the thing that we have obtained, and this would be very much easy to understand that this were the basically the methods of preparation of an alkene. So we could take any one of the alkene alkynes, and we could prepare alkene in that manner. So just for a small instant, let me recap all those things by solving the question that we have right now with us. That is this one. So this would be a very recap, and it would be better for us to understand that how can we solve this equation. So the thing that has been provided to us is write the chemical equation for preparation of but1-ene, as well as we have to prepare but2-ene from alcohols, from alkyl halide, and from vicinal dihalide. So talking about the first thing that we have to prepare for but1-ene. So this is the thing that we are going to prepare. So now let me talk about that. That is formation of but1-ene. That is, the first thing is from alcohol. So but1-ene, or we could say that butene, consists of basically 4 carbon atoms, and that 4 carbon atom would consist of a carbon-carbon double bond at carbon number 1 and between carbon number 1 and carbon number 2. So this is the thing that we have to prepare. So we have to prepare it from an alcohol. So how can we prepare that? So that is the main concern. So suppose I would write the reaction in this manner, where we have to prepare basically but1-ene. So that I could write the structure as CH3 CH2 C double bond CH2, and here it is CH. So this is basically but1-ene. But I have to prepare it from an alcohol, and let me tell you, in the overall reaction that we have studied today, that is during the formation of an alkene, there was no change in carbon atoms. The number of carbon atoms would have been the same. So that's the reason, if I found that the number of carbon is been obtained as 4, then the reactant should also have the carbon as 4 atoms only, that should also be in a straight chain. So therefore, and that too, it should be an alcohol. So I could write it as CH3 CH2 CH2 again CH2, and here it is OH. So in this case we have considered 4 carbon atoms here, and along with the OH atom that has been attached over here. So therefore we have to convert basically an alcohol, and the name of this alcohol is basically butane-1-ol, or basically butanol, and we have to convert this into butene. So because it is an alcohol, obviously we have to use H2S4, and moreover it is a primary alcohol, so that's why we have to use basically 95% of the concentrated H2SO4, and we have to heat it. And in this case basically what will happen is, because of the beta elimination process, this OH will be removed along with that of the, suppose if this is an alpha carbon atom, then this would be the beta carbon atom, then one hydrogen of the beta carbon atom would be removed in the present in the form of basically H2O, and now we could obtain basically the product. So this is how we have obtained that is butene from butane-1-ol. So this is the first thing that we have did, and the second thing that we have to do is, yes, we have to prepare it from an alkyl halide. So how can we prepare that? Let us talk about that also. So this is the same thing that we have to prepare, basically but1-ene. So therefore I am considering to prepare it from an alkyl halide, that is from alkyl halide. So the thing that we have to prepare, yes, it is basically the same but1-ene. So therefore I would write the structure as CH3, CH2, C double bond CH2, and here as H. So this is what we have to prepare, and we have to prepare it from alkyl halide, and moreover in this reaction no change in carbon atom had been occurred. So therefore if I am obtaining a 4 carbon atom as a product, so therefore the reactant should also consist of a 4 carbon atom, and the hydrocarbon would be of basically of 4 carbon atom. So since this is an alkyl halide, so I would consider in this manner that the alkyl halide would be CH3, CH2, here also CH2, and here it would be CH2. And since they have not specified which halide it is, chloride, bromide or iodide, so that's the reason I could take any one. So I would mention it as here as bromine as an atom, or which has been attached over here, making this molecule to be called as 1-bromo-butane. And this is just a recap that we have already did. So if you have to convert an alkyl halide to an alkene, then the only reactant that we are going to use in this case is basically KOH. So therefore what we are going to do is we are involving it with the alcoholic KOH. So among this K, that is this potassium, will take away this bromine, and this OH will take away the, if this is alpha and this is beta, again this OH will take away the hydrogen of the beta carbon atom, and so as to remove as basically KBr and H2O. So this process will occur, and obviously we would convert 1-bromo-butane to basically but1-ene, that is this one. So now let us talk about the another one that we have, that is we have to convert a vicinal dihalide to basically but1-ene. So how can we convert that? So that is what we are going to talk about, that is we have to convert it visceral dihalide to but1-ene, that is we have to prepare it from vicinal dihalide. So the thing that we have to prepare is basically butene, that is I would write over here as CH3, CH2, C double bond CH2, and here it is H. And the next thing is we have to prepare it from dihalide. So I could write in this manner, that is CH3, and yes, we should be assured that the two halogen atoms should be at the adjacent carbon atoms and it should not be far apart. So therefore CH2, CH, here it would be, I could consider any one of the halogen atom, so therefore this would be Br, and again this would be CH2 Br. So if I want to convert this dihalide to that is an alkene, basically known as but1-ene, so I have to use zinc in presence of an alcoholic condition, and I have to heat it. So therefore zinc will take away this 2Br to be removed as ZnBr2, and the name of this would be, I would consider the name as 1,2, that is dibromo-butane. So this is how we have converted those molecules to but1-ene. So now let us talk about the another one, that is the first question is now been done, that is we have easily converted this all to but1-ene, and now we are talking about the formation of but2-ene. So let us talk about that also. So now we are going to talk about formation of but2-ene. Again from the same condition that we have discussed about earlier, because the question has been given to us, that is we have to prepare it from an alcohol, from an alkyl halide, and from vicinal halide. So talking about the first one, that is from alcohol. So suppose if we have to prepare basically but2-ene, so but2-ene is nothing but CH3, C double bond, C CH3, and here it is H and H. So this is the main factor that we are going to talk about. So suppose if we have to introduce an alcohol, so the alcohol or the hydroxyl group that should be attached, it should not be on the primary carbon atom. It should be on the secondary carbon atom at least. So this is what I want to explain. Suppose that is, if I have introduced or if I have taken the OH on the primary carbon atom, then obviously I would have gotten one butane. But in this case, suppose if I am attaching the OH on the secondary carbon atom, so this indicates that there is a possibility of formation of double bond over the between second and third. The reason behind that is, suppose if I name or if I number this thing, then this carbon atom would be considered as the 1, 2, 3 and 4. So the elimination reaction or the beta elimination could take place, that is between the carbon number 1 and carbon number 2, or else between carbon number 2 and carbon number 3. So in this manner, suppose if I take the secondary alcohol, like the name of this would, if I would consider, the name of this one would be basically butane 2 all. And if it undergoes dehydration process, that is removal of OH and H, or basically removal of H2O, so that will give us basically but-2-ene. But the reagent that should be used in this case is basically H2SO4. And again, I would recommend for a concentrated H2SO4 solution, so as to we will get this as a major product, and this is based on the seeds of fruit. And what is the seeds of fruit we'll discuss about in future also. So this is what we have obtained but-2-ene from alcohol. So let us discuss about the next one that we have wanted to explain, that is from an alkyl halide. Again, it is very similar to that of the thing that we have did here. The only thing that we have to do is we have to replace this OH with an halide group. So let me explain it. So the second thing is we have to prepare it from an alkyl halide. So the alkyl halide that we could take is basically CH3, CH2, CH. Halide could be anyone. So let me take it as suppose Br again, and this is CH3. And always an alkyl halide undergoes the reaction with alcoholic KOH. In this case, what happens is this Br will take away the potassium, and this OH will take away, that is, the beta hydrogen atom. So it won't be this one, it can be this one, but the thing is, if it is removing the hydrogen atom from this beta, then the but-1-ene will be obtained, and if the OH will remove this hydrogen from this beta carbon atom, then the double bond will be present over here. So therefore the thing that we could obtain if the reaction will take place in this manner, so therefore we could get CH3, CH double bond, CH3 as a major product according to the Seid's rule also. And the only thing that would be left out in the terms of the byproduct would be KBr and H2O. So the name of this would be, that is 2-bromo-butane. So now let us do the last one, that is from, so in the earlier one, that what we have took for us to prepare but-1-ene, we have took the 2-bromine to be aside, that is on the carbon number 1 and 2. But now what we are going to do is we are now going to take the vicinal halide in such a manner that the bromine should be attached on the carbon number 2 and carbon number 3. So therefore what we have to take the vicinal halide that should be attached on the carbon number 2 and carbon number 3. So that is the reason that I am taking it as, the molecule should be in this way, that is CH3, CH, here it will be CH and here I will write it as CH3, and I could take any halide. So suppose in this case, suppose I am taking as chlorine, suppose in this case, and I am reacting it with zinc in presence of an alcoholic condition, and I will heat it. So what will happen is zinc will remove this two chlorine atoms in the form of ZnCl2. And the only thing that will be obtained is basically CH3, CH double bond, CH, CH3, making this to be known as but-2-ene. But this has been formed from a visceral dihalide which has an IUPAC name of, basically I would number it as 2 and 3. So this would be named as 2,3 dichloro, and the total number of carbon that is being present in a straight chain in this case is basically 4, so making this to be called as butane. So this is how we have prepared. So these were the main things, or the main methods from where we could prepare an alkene. So this method has been clearly being showcased. I hope you have understood this very clearly. So thank you friends for watching this video. I hope you have understood this video very clearly, and you have also got to know the concept of how to manage or how to write the chemical equation. So share this video with your friends, and yes, don't forget to subscribe to Ekeeda channel. Thank you so much.